All right, so this is the synthetic division, which I like better than long division, but actually I don't even mind long division. All right, so we're going to do remainder theorem, and remainder theorem is pretty simple. If you plug a number in and you get a 0, it was a 0. So I'm going to do two of them here. I'm going to do x equals 3, and what we're going to do on paper is we're going to say, okay, 3, here's my function, to the 4th minus 4 times a 3 that's cubed, right? Minus 8 times a 3 plus 32. Now, I don't exactly expect you guys to do that in your head. It'd be really cool if you did. This is what I expect you to do. I expect you to plug a 3 in. I feel like using the storage feature here because I'm going to be doing another problem with the same exact thing. So I'm going to take a 3, I'm going to store it to x, and then I'm going to type in the polynomial itself, which was x to the 4th minus 4x cubed. Of course, you can do this with graphs too. Don't forget that. Might even be worth showing. Plus, that establishes the relationship between, x-intercepts and zeros and stuff like that. Anyways, I got a negative 19. So this is not a 0. What we just learned here was that f of 3 is equal to negative 19. So it's the remainder. But most importantly, this is not a 0. All right, let's do the same thing with number 4. On number 4, x is 4, so I'm going to take a 4, I'm going to store it to x, and then I'm just going to type in the polynomial, which I've already done once. Notice I'm arrowing up and highlighting and pressing enter. Play along, learn how to use a calculator, and I get 0. So I forgot to show my work here. My work was that everywhere I saw an x, it was a 4. And I just learned that, by the way, this is what f of 4 is. I'm letting x be 4. Some of you still have not figured out f notation. But I just learned that f of 4 was in fact 0. So here's what I know. I know that x equals 4 is a 0. If I just shift that left, I get the factor. X minus 4 is a factor. That's how this stuff works, man. All right, let's move on. What have I got bolded here? I have number 8 bolded. I wish I could get rid of this thing. I don't really want it in my way. Let's put it down there, and it came right back. All right, so you're supposed to do synthetic division here on number 8. The big issue we have with synthetic division in kids is this inability that y'all seem to have to accept that signs have to change every once in a while for the problem to be done right. That's the common mistake. So we're dividing by x minus 3, and the way this works is we hope x minus 3 is a factor. So again, we hope x minus 3 is a 0. So that makes x equal to 3 if we just do a shift right operation. Let me check and see what my instruction set were. If it is a factor, completely factor the given polynomial. So let's do synthetic division. You've got your vinculum, it's 2 stories tall. You load it only with the coefficients. Now this one actually needs a placeholder. You've got 1x cubed, you have a negative 5x squared, you have a 6, but you don't have any numbers, and you actually need that placeholder. It is a very, very common one for kids to forget about, because if you glance at it, doesn't look like you need one. But you're dividing by 3. We drop, remember the acronym here? DMA, drop, multiply, and add. You drop the 1, 3 times 1 is 3, negative 5 plus 3 is negative 2, 3 times the negative 2 is negative 6, you get a 0, and that's a 0, and that's a 0. Now, if you're wondering why I needed that, I just kind of did. You have a remainder, a constant, an x, and an x squared. On this problem, it wasn't a big deal, but there's somewhere it is where you have to actually include that number. So anyways, if I think about what I have, I already know that a factor is x minus 3 because it went in evenly, a remainder of 0. And what I have left is x squared minus 2x. Which, by the way, is why that was required, because otherwise you would have thought this was the remainder and this was the constant. That's why it's required. Now, this will still factor. You can pull an x from both pieces. So you got your x minus 3. if you pull an x from x squared, you have an x left over. If you pull it from minus 2x, you have a minus 2. Now, mathematicians like to put the x out front, and you should too, because you're modeling success, right? If you want to be the man, imitate the man for a while, and eventually you'll get there. And there you go. Not a hard problem for some. I think it's pretty simple, but, you know, that's me. Given the polynomial f of x and the factor of f of x, factor f of x completely, and it says that the divisor is not simple, so you have to use long division. So this is actually yesterday's lesson. It's just a review question to remind you of yesterday's lesson. There was a second one, but I felt sorry for y'all and I shortened the assignment. None of you will say thank you, because you're probably not listening. Just being honest. But it's a long one. This is long division. Long division is long. We're dividing by x squared minus 3. Now when I write my dividend in here, I'm going to include placeholders. There's an x to the 5th. There's no x to the 4ths. Minus 3x cubed minus x squared plus no x's plus 3. And moving forward with our lives, right? I want to turn x squared into x to the 5th, and I believe that I can do that by multiplying by x cubed. Now x cubed times x squared is x to the 5th. X cubed times a negative 3 is minus 3x cubed. Again, remember we wrap before we subtract. The x to the 5ths disappear, the 3x cubes cancel each other out, and we're going to have to bring down some more stuff. A negative x squared plus no x plus 3 is all going to get brought down. I'm probably going to need it. Now, how do I turn x squared into negative x squared? Well, I use a minus 1. That'll give me the negative x squared, and the negative times the negative is a positive. And again, wrap before I subtract, and I got a remainder of 0. So I was told it was a factor. It turns out it was a factor because the remainder was 0. It went in evenly. That's how we say it, evenly. Went in evenly. Now, turns out that what I have so far is I have the given factor of x squared minus 3 times x cubed minus 1. Now, believe it or not, x squared minus 3 factors. I'm going to do it for you, but I want to talk about this one first. This is an x cubed minus a 1 cubed. And, you know, you're supposed to remember formulas. Nothing I can do about that, but you're supposed to remember some things. You're supposed to remember that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. You're supposed to remember it. Do you? No, because you can't even remember the formula for slope. Bless you, child. So, a minus b, that'd be x minus 1. The next piece over here, and we're going to save factoring complex numbers for quite some time, is going to be a squared, x squared, plus 1 times x, x, plus 1 squared, which is 1. Now, where we're at right now, leaving this alone is good. It's really, really, really good. It's not completely done because we haven't factored over the irrational number space, but it's pretty darn good, and that's good enough for where we are right now. All right, moving on. The next one I have highlighted for me to do is number 11. We are given a 0 factor completely, and we can do synthetic division on this one, by the way. But first we need to understand that f of 7 is a 0. That means that x is what? What is it? If f of 7 is a 0, what's x? Right? That's the thing I've noticed in y'all are misunderstanding. It's good old function notation. And I don't know why. It's so easy. F of 7 being 0 says x equals 7. Shift it left. X minus 7 is a factor. This is not rocket science. This is factoring 101. Now, since x is 7, that's the guy we're going to divide out. My marker is leaking all over me. It's a good marker, I guess. We're going to take the x value, put it on the second floor of the vinculum outside. Coefficients are 10, negative 81, 71, and 42, and I did not see a need for any placeholders when I glanced at that one. Again, your acronym here is DMA, drop, multiply, and add. We drop the 10, 7 times 10 is 70. We add negative 11. 7 times negative 11 is negative 77. 71 plus a negative 77 is negative 6. And 7 times negative 6 is a negative 42. And you got a 0 that was expected. It was expected because you were told it was a 0. Right. Remainder constant x squared. 10x squared minus 11x minus 6. And the existing factor, x minus 7, again, we're supposed to factor this thing as far as we can possibly factor it. So we're going to keep factoring. My gut says to make a 10x squared, I'm going to use a 5x and a 2x. I made this problem back in 2020, so, you know, I don't remember what it is. It's not like I made it up yesterday. To make a 6, probably a 3 and a 2, and I'm good with that, 3 and 2. Outside makes 15, inside makes 4, a negative 15 plus 4, 1 done, bam. Now, did I have to do anything else? No, I just had to factor it. I did not have to use zero product property. It never said solve, it just said factor. And she's factored, boys and girls. Easy peasy lemon squeezy. All right. What else we got here? I could have sworn I was choosing to do one of those two. Number 12. You are given an expression for the volume of a rectangular prism. Find an expression for the missing dimension. Remember, you can do synthetic twice. These side lengths, which you can't see my hand over here, these side lengths are actually factors of that problem right there. So we're going to think about what the actual x values are. X minus 1 is a 0, which means x is 1. And x plus 6 is a 0, which means x is negative 6. And we're just going to pick one of these and go. I'm going to go ahead and do the 1 since it's small. In math, if you do the easy things first, it makes the next line easier. Of course, for some of you, none of this is easy. I wish you could get to the point where it was. All right, we're going to drop that one. Remember, it's drop, multiply, and add for eternity or until you get done, right? 1 times 1 is 1. I don't have any sign mistakes, do I? 13, 34, negative 48. All right, looks good. If you put a 13 and a 1 together, you get 14. 1 times 14 is 14. 34 plus 14 is 48. 1 times 48 is 48. Put them together, you get a 0, as expected. And remember, with synthetic division, if you get a 0, you just keep going. Wish that blue marker worked better. I just don't know what's wrong with her. But if you get a 0, you just keep on going. So let's do the negative 6 now. I'm still going to drop that 1. Negative 6 times 1 is negative 6. 14 plus negative 6 is 8. Negative 6 times 8 is negative 48. 0. Remainder constant x. This is the missing factor. This is x plus 8. That's what goes in that question mark right there. X plus 8. Easy peasy, lemon squeezy. I feel like one of these was bolded, but I sure can't see which one it was. I think I'll do completing the square. I know that I had bolded one of them for me to do. Probably should underline it, because when you transfer over to the software on the glass, you don't see everything like you usually see. So I'll do 2, which is complete the square. Wouldn't kill you to learn how to complete the square. You're solving 16 over here off to the right, that guy right there. You're solving that by completing the square. This guy right here, by the way. And the constant's already been moved to the right-hand side, so my next line is going to be to divide everything by 6. If I divide 6x squared by 6, I have x squared. Looks like take away a 2x, and if I divide a 6 by 6, I get 1. Very next move in the complete the square technique is to take half of whatever b value you have on this line. So you're going to take your negative 2 and you're going to cut it in half, and you're going to get a negative 1. You're then going to turn around and square that negative 1 and get a 1. And you're going to add that to both sides. That's how she works. Now, the left-hand side takes an x and an x to create x squared, takes a 1 and a 1 to create 1. Negative 1, take away negative 1 is negative 2. And if something is squared, it sure was written twice. And you look like that. Now the opposite of squaring has always been square rooting, and it always will be square rooting. You just have to do it at the right time. Remember, if you don't include plus or minus, you forgot an answer. It was originally an x squared, which means 2 solutions, kids, 2 of them. The square root and the square knock each other out. You got plus or minus root 2. You shift your 1 over to the right. X would be 1 plus the root of 2, or x is 1 minus root 2. And, you know, these are conjugates of each other. Weird answers where you have irrational numbers or imaginary numbers, they always occur in conjugate pairs. That is a big deal coming up. Hurry up and learn what a conjugate is, okay? Anyways, that's the homework I'm doing for you. I hope you enjoyed. It was 15, almost 16 minutes of my life I gave you. Give it back. Work. Make it worth it, kids.